This little guy is a system of equations, so you gotta simplify them and then substitute one into the other. The subtitle's right here. If you can't do this, you're screwed, because this is not the only system we're gonna encounter. This is just a radical. You square both sides, and then you square both sides again. I'm not really sure what's so scary about it. This one's also pretty simple. Just combine like terms and do the algebra. This is actually technically wrong. There's two real solutions to this, but it says the value, so oopsie. This one's even easier. Just look at it. Obviously there's no real solution. I don't know why it says only 3% of people get this right. You could probably show this to a 6th grader who's just learned what an exponent is, and they'd probably get it. This one's another system, and I lied earlier. You can solve this through substitution, but that takes a really long time. It's a lot easier to cross multiply and then just divide the two expressions. Here we have a percentage, not the last one you'll see. If you see one, the first thing you should do is just convert it to a fraction. It'll make your life so much easier. Here we have our first exponential. You should immediately try to get the bases to match. 25 is 5 squared, and then combine, and then logarithm, and it's pretty simple. I find it hard to believe a question like this would ruin someone's perfect score. Here's another exponential, slightly harder than the last one, but again, just manipulate the bases and boom. This one's incredibly stupid. The video actually recommends just brute forcing your answer, because there is a cubic formula, but it's... no. The correct way you should go about something like this is the rational roots theorem, which I know you learned, but I wouldn't blame you for forgetting it. This one's yet another exponential. Again, you've got to get the bases to match. If you're in the apparently 90% of people who get this question wrong, you probably should not be taking the SAT. This one's actually a geometry problem. You need calculus to do the algebraic method for finding the minimum value of a function. It's a lot easier to just recognize that this is a quadratic, so the graph is a parabola, so the lowest point is when x is equal to negative b over 2a, and then just plug everything in. This is the easiest question in this entire video. Just don't do what the thumbnail says. Here we have another percent. Of means times, percent means divide by 100, and solve, and yeah, this one's pretty easy. The trick that no one taught you in the title is up to your imagination, of course. As a former Googologist, I can tell you this is bullshit, but hey, it's just another exponential, I guess. Still technically wrong though. More percent action. Again, percent divide by 100, of is times, and just crunch your way down. This is a bit sneakier. You square both sides, then you square both sides again, and then just solve for x. I'm not really sure what the trick here is. This one's even trickier. You could do the convert to a fraction and divide. There's no way in hell you're mental mathing 55,200 divided by 92, so I guess you just gotta... This is by far the hardest question in the entire video, okay? You have to expand the factors in exactly this way or it just won't work, and then you gotta do the quadratic formula for just these ridiculous numbers, and if I came across a question like this without doing the research for this video, I would just myself. This is a sweet little vertical angles problem. Don't let the fact that the angles in the diagram are not to scale fool you. Here we have an absolute value problem. Make sure to remember that the thing on the inside of the absolute values is what's plus or minus, not the thing on the other side of the equation. That's how you end up with extraneous solutions. In this case, it's fine, though. Here we have an exponential system of equations. This one's really tricky, because you can't actually solve for x and y. You actually have to substitute into the exponent to get this one. This is not the last of this type of equation we'll see. Here we have more roots, just simplify them, I don't know. Another percent question, but this one's a bit more involved. Just make sure to convert it back into a fraction before you choose your answer. Here we have a pretty sneaky exponential. You have to combine the like terms and then do the logarithm. I can see why this trips people up, but again, once you spot it, it's trivial. Whoever makes the graphics for this channel probably got fired after this video released. You're supposed to take the area of the square and subtract it from the quarter circles, of which there are 4, so it amounts to a square with side length 6 minus a circle with a radius 3. Or if you go by the literal interpretation of the question, 0. This one can be brute forced, but it's easily solved by knowing that the number of people in the room is equal to the number of people shorter than Derek, plus whatever his position in the tallest people list is. This one's obvious, but proofs are difficult, so just do the process of elimination to be safe. This is a really difficult radical, but it's not hard, it's just annoying. You gotta just peel back the layers. Eventually the answer will reveal itself. This one is incredibly easy if you know a bit of geometry trivia. Alternatively, you could split the pentagon figure into 3 triangles, and the interior angles of all these triangles add up to the interior angles of the pentagon, and you should be able to solve that problem pretty easily. Obligatory, no, it isn't the hardest SAT question ever. That's just clickbait. This one is quite interesting. Everyone knows 0.9 repeating is equal to 1, but that's a geometric series limit problem, and if you don't know what that is, well, don't worry about it. This is another one of those combined like terms exponentials. You know how these go by now. This guy's a bit finicky. The best way I can explain it is it's similar to how you have to plus or minus the square root when doing a quadratic, but it's still a bit annoying. This is a really strange one. It involves a lot of pattern recognition, and no, not the racist kind. You have to figure out that 4 times 4 is 16, which ends in 6, and 4 times 6 is 24, which ends in 4. This means that any numbers ending with 6 or 4 will, when multiplied by 4, just cycle around to the other one. Any question with ridiculously large exponents involved is likely one of these. It gets actually hard because coming up with this on your own is quite unlikely. Here's another exponential. You could do the fancy way and solve for a first and then square root, but that could get you into a bit of trouble if you plug in a instead of its square root for the answer. Here's another exponential system. This is, exactly the same as the previous one in how you solve it. This is a combined like terms exponential, but you do have to do a bit of dividing to get the answer to reveal itself. This time you have to manipulate the exponent. This one is there's so much wrong with this. You can actually get an answer, but it involves non-elementary functions and analytic continuations and I don't know what this has to do with Harvard, by the way. Whoever came up with this title and thumbnail should feel bad, actually. This is a pretty famous one. It's just a divide by zero error. Some people who think they deserve to live will say stuff like, oh, but anything to the power of 0 is 1, so it has to be 1, but don't listen to them. Just like getting into Harvard, which this channel loves to clickbait for some reason, there are no real solutions. It's the negative square root. In this exponential, you have to manipulate the bases so that the exponents match, then you can compare them. This one is extremely strange. Once again, converting your percents into fractions pays off. And again, it's really easy to trick yourself if you don't do that. This is another combined like terms exponential, but it's extremely long-winded and annoying, and requires you to know off the top of your head that 6 cubed is 216, which is not very likely. Here we learn that nearly 5 million people want to learn how to do their percents. This one's an exponential as well, but it's not immediately obvious. You just need to find out you have to substitute the 2 in, and then everything else is easy. This is another last-digit multiplication loop problem, but this one's a bit more involved. This is an exponential, but it requires a bit of solution by inspection. Not too much though, it's still pretty neat. For our penultimate question, yeah. They do have to include these easy problems, just so there's a way to differentiate between the different tiers of bottom achievers. This one has some square roots in it, so square both sides, and it simplifies pretty nicely. And we're done. I think. Maybe. I've never actually taken the SAT before.